Thank you for letting me present at this conference, and welcome to my presentation on the security implementations of IoT in a 5G future. My name is St John Harold, and I'm one of the senior managers at the Cyber Risk and Advisory team of the BSI Cybersecurity and Information Resilience team. We're a consulting group that's based in Dublin, and we are part of the BSI Global Group, which is an international organisation based out of London. We are one of the world's oldest and first national standards body, and one of the original publishers of the ISO 27001 framework. And all that's the family of cybersecurity standards. I have approximately 20 years within the information security domain, and I've covered both consultancy and also security analytics using artificial intelligence to derive some quantitative analytics. So this presentation is focused on the use of the Internet of Things and its future interaction with 5G. What I'll do first is I'll explain what the 5G infrastructure is and why it's a good communication technology for the IoT devices. Then I'll explore the potential security architecture models that are available for an IoT device. And from that, I'll move on to talking about the information security risks associated with that architecture and examine the various mitigation approaches. So 5G, the fifth generation network for mobile use, it is a new global wireless standard. It delivers a new kind of network and is designed to connect almost everyone and everything together. The benefits of the 5G is the multi-gigabits per second peak data speeds, magnitudes order faster than a 4G. It's the ultra-low latency. It's the ability to be far more reliable in the different areas of where we're trying to use the IoT devices. It increases the network capacity significantly, so allowing more devices to connect up, and should provide a more uniform end-user experience. When combining 5G with the IoT opportunities, it should enhance the operational capabilities of these devices. And it will, of course, become a core critical national infrastructure by the end of this decade. But with all these things, it also introduces new risks. And we'll come across those risks a little later on in this presentation. I should also point out that there is a big difference between the 5G implementation and an IoT implementation. And this is basically around the standards that are available for either architecture. 5G is highly regulated and has been built upon a very recognized set of standards which have been issued by industry groups such as the Third Generation Partnership Project and the United Nations International Telecommunications Union. The IoT devices have not followed the same processes, and they are largely unregulated and have no generic standards that they can follow. There is, of course, a BSI standard on how to build an IoT device, should you want to follow that. But it's not been internationally, it has been internationally recognized, but it is not being used by all IoT manufacturers. So now I'm going to sort of talk about how the 5G architecture works. And it consists of the core network, the core network gateways, what we call here the radio access network, which is otherwise known as RAN. And between the end users and the RAN network is the wireless spectrum that is used for 5G. And of course, that is different from the 4G environment. So in principle, it looks like the 5G components are largely similar to the 4G components. But there are some key differences. And those differences are around the fact that the hardware now, for routing capabilities, has now developed from a software-defined network capability. And so it now allows network function virtualization. And also, because of the improvements in the communications at this layer, it now means that multi-access edge computing occurs here. So this allows some of the applications that used to be hosted here to now be hosted on the actual IoT devices here. So this has created the concept of edge computing, and it's moved the processing closer to where the data is. So instead of having to send the data across the networks into the cloud and then do the processing and then send it right back, what we're able to do is shift that whole control plane and allow the data to move between the IoT devices here. But this, of course, has changed the cybersecurity landscape, and it has now become a decentralized model. The change does allow for lightweight application processing, as I've just mentioned, to occur here, and the services which can be managed either by the IoT devices or at the core network gateway interfaces to decide whether this is heavy processing or lightweight processing. Should the heavyweight processing be required for maybe machine learning or other forms of and applied intelligence, then they can shift the data quite quickly down to this side here and just let the hardcore processing happen there. So now you can see the symbiotic relationship between the 5G and the IoT devices. So now we're going to start to look at what makes up an IoT device. And as you can see, the key components are the sensors that sit here, the hardware that connects the sensors up to the actual IoT device. Then there is a layer of software that will sit on top of that hardware to do the computing and managing of the hardware and the sensor data. And then there is a communication interface also connected to the hardware, which then allows that 5G connection. So with the ubiquity of the IoT devices and the increased growing interest in security and privacy, which is also important to remember, there is now a need to start to think about formalizing the security architecture model. So this slide provides three potential approaches to describing the security architecture. And as we move between the layers 3, 4, and 5, so we can start adding more granularity to the actual architectural model. The issue, according to the IEEE, is that there are many architectural models that have been presented for describing an IoT device, but because there are so many different ways to design, build, and use an IoT device, trying to create that generic security architecture is very, very difficult. Some of the models that have been proposed include the reference architecture model industry, the industrial internet reference architecture, and Cisco's Internet of Things reference model. But the majority of these models tend to have suggested a layered approach, which is what we have here. And this layered approach will allow the manufacturers to identify at the correct level or at the correct layer the right security controls that need to be implemented. I'll first start talking through the three-layer model. As we can see down here, we have the perception layer. This perception layer can otherwise be referenced as the sensor layer and is the interface of the sensors. As we saw in the earlier slide, those sensors could range from a multitude of things, maybe an RFID detector, or a 2D barcode reader, or it's a video camera, or a microphone, or a drone. As you can see, the range of sensors that are available are immense. And of course, you only choose the right sensor for the actual application and functionality of the IoT device. Then as we move up to the network layer, this can also be where we might consider the transmission or the transport layer, similar to the OSI model. And this will be the bridge between the perception layer and the sensors and the application layer, where some higher level functionality will occur at the software layer. So what happens at the network layer is that the information from the sensors are captured and processed and can then be sent via the communication interface down into the 3G network. That network layer is also the interface to the actual network infrastructure and provides the front door for the IoT device. And then finally, here at the application layer, this is the software that interfaces with the hardware, the sensors, and the communication path, the interface for the 5G, and will provide the logical services that allow the IoT device to function correctly. So we'll move on to the 4-layer model. You can see it's very similar to the 3-layer model, but there is an additional layer between the network and the perception layer, which is called the support layer. This is the layer where we can start implementing privacy and security, and this layer has been implemented to allow for authentication. So it could be a place where the secrets key or shared secrets or even just plain old passwords are interfaced and exchanged and managed at this point. So the reason for adding in the support layer is to provide more granularity to the security architecture model. And also at this support layer, it does provide that interface into the 5G wireless connection and manages the communication controls through that point. So now we can move on to the 5-layer model. And you can see here what we've added in is the business layer and the processing layer. You'll also notice that the transport layer has been changed slightly, but it still represents the same as the network layer here. The business layer, if we go straight to the top up here, the business layer is the software layer that controls the functionality of the device and acts like a manager controlling the applications and the business logic and also the sensors and communications all at the same time. And in this 5-layer model, this is also where the privacy controls are placed. If we look at the processing layer, this is also referred to as the middleware layer, and it collects the information that is sent from the transport layer, from the network interface. And in this 5-layer model, what it's able to do is strip out any unwanted information or any unwanted data in that data packet, strips it out and removes it, and only sends to the application and business layer the required amount of data. This is really important within this decentralized model that we mentioned earlier, because what we can now do is just refine the information that is processed by the IoT device to only process, as I said, the information that it needs, rather than giving it all the information and then letting the application process it all, spend extra cycles doing munging on that data, which is not necessary. So one of the advantages of applying this processing layer is that it can start to reduce the concept of the big data problem for an IoT device and reduces the volume of data that needs to be processed at the application layer. So now we'll move on to what the risks are to these IoT devices. But technically, what I'll be really mentioning is what the attacks are at each of those layers that we've just mentioned in the security architecture model. The attacks, when combined with a known or unknown vulnerability in the system, and when we understand what the impact is on the data and how important that data is that sits on that device, only then can you start to put together a proper risk understanding and a risk rating. But for this purpose, we'll talk about the attacks and assume that at each layer there are vulnerabilities that could be exploited. But we won't actually give a criticality level to those or critical rating to those risks during this presentation. So as we said, the IoT, new era of opportunity with the IoT devices connecting up to the 5G network, but it will introduce risks. And what I'm going to argue is that the current risk methodologies and the risk management assessment, and the risk assessments, they're currently not designed or fit for purpose for actually identifying in a thorough and repeatable way the IoT-related risks. So we need to start thinking about how we can develop these approaches to risk managing IoT devices and come up with a new formal risk management methodology. You've got to remember that these devices are connected to the 5G network and will be pervasive and be on all the time. And therefore they are now opening up the attack surface, not necessarily from a protocol perspective, but from the fact that they're available all the time on public networks. Sometimes. The kind of attacks that they'll be vulnerable towards are still pretty much standard ones that affect ordinary on-premise networks and the communications to the internet from these on-premise networks. And there's still the eavesdropping, impersonation, man-in-the-middle attacks, the denial of service, stopping at the infrastructure level, stopping the packets leaving or arriving at the interfaces. And of course, replay and repudiation will be others that's still affected here. So perhaps what I'm going to recap now is probably a story around how a traditional risk assessment methodology may overlook some of the vulnerabilities and attack methods that could be used with IoT devices. So if we examine a smart home implementation where there's a voice-activated device that's connected up to an IoT-connected lock on your front door. Now the benefit is that you can sit at home, sit in your armchair, open the door without ever having to get up from the couch, just by a single voice command. But it also means that the thief or a burglar who is identified that you've left the house, gone out, can come up to the front door, open the letterbox, and shout the same command down through the letterbox and get free access by opening the door into your house. So this would not necessarily be picked up by a repeatable standardized risk assessment methodology or even a threat picture via the threat modeling process. So the issue here is a lack of authentication at the IoT device and not necessarily having that device to recognize only the homeowner's voice. Now these devices, today they can be set up to understand the owner's voice and block those that are not or have not been registered to that device. But how many people at home with these devices actually do that in a home environment outside of the enterprise? And so these are some of the risks that we need to start thinking about when these devices are also connected up through these remote working that we're currently running in this COVID situation. 5G will still suffer from the same 4G security vulnerabilities. And the key reason here is that it is not possible at the moment to roll out a dedicated 5G network all at once. So places where 5G networks are only partially implemented and exist side by the 4G hardware and software components for an extended period of time will suffer from the same risks that affect just a 4G rollout. And these vulnerabilities are well known at the moment, so I won't run through those right now. Other than the fact that obviously it's the denial of service, there's spoofing and misrepresentations, which are obviously current now in 4G and will still be current in that 5G hybrid 4G environment. Now, I'm just going to quickly run through the layers here and sort of identify the different styles of attacks that can occur, which focus really mainly on the IoT layers rather than the generic on-premise style attacks. So here at the perception layer, we'll use the 5-layer model. So the perception layer, it's going to suffer from eavesdropping between the communication device, the IoT device, and the actual masts. There'll be a node capture potential, i.e. someone could spoof one of those masts, insert their own mast receiver, and try and get the IoT devices to talk to that. There's also the fake node and sort of malicious attack approach, where the attacker has compromised an existing node and is therefore able to manipulate the data in real time that's going through that node. Other attack considerations which are fairly standard across communication networks will also be the replay attack, and that can build on the node attacks previously mentioned. There's also timing attacks which can take place where you can try and do some cryptographic or try and get the crypto algorithms to do something, maybe the passwords, and through the timing attack process there you can observe how long it takes to execute that algorithm and learn some potentially sensitive information from that process. And again, at the network layer, transport layer in this model here, you're going to start to see the traditional attacks, which is the denial of service, man in the middle, storage attacks, exploit attacks, where an attacker can compromise whatever is vulnerable. Then we'll go up to the processing layer here, the application layer here, and we'll talk about, at the application layer, there's going to be the traditional application layer attacks, and they will be cross-site scripting, injection commands. They'll also include the malicious code attacks, where you're trying to manipulate the code of the application, and all those other traditional web application attacks. Obviously, the way forward is for application-style interfaces, APIs to communicate, because a lot of edge computing is going on here, and that API now standardizes the approach that the various devices can use to talk to each other. You can also start to think about, at the support layer, attacks here would be very much based around denial of service or malicious insider attacks. And again, very traditional attacks. At the processing layer, if we go back down to the processing layer, there are numerous attacks at this layer. And they will revolve around maybe exhaustion attacks, where you overload it with resource requests, just bombard it with HTTP requests perhaps, or you upload somehow, depending on the vulnerabilities that are available, the malware, which will then allow whatever the vulnerability you're trying to exploit to execute that malware. Again, very similar problems to current web application interfaces. And even at the business layer, still going to have the same style of traditional attacks here, and they will be an end user who gets access to that business layer logic, trying to manipulate the logic to get it to do something that the code allows it to do, but you wouldn't normally expect the business process to allow. So it's just trying to overcome logical flaws in the implementation of the programming. And of course, there's always the ubiquitous zero-day attack, which can affect every and any layer. So having described what the attacks are and how they will exploit traditional vulnerabilities in the same way that they're implemented on-premise or in current cloud environments, the IoT device will still suffer from those same coding errors, misconfigurations, and what have you. But I'm not going to run through the traditional mitigations, because they are well covered and well discussed throughout the years. Instead, I want to focus on sort of the risk mitigations that are specific to IoT devices and the 5G network. So to achieve a strong IoT security baseline, it will take a multi-layered approach. And this is where the 3, 4, or 5 layered model will help on that. So a key thing here is that the security team will need to understand how 5G works and where the computing power will happen, how the computing decisions are made, as whether it's lightweight processing or the heavyweight processing back in the cloud. So once you understand that full end-to-end process and all the protocols involved in trying to shift that data and manage the data and take advantage of the speed and latencies and volumes of traffic data there, you're not going to get a full picture of how to understand or analyze those risks. In this decentralized approach that we talked about earlier, this edge-to-edge computing, it's going to require the ability to share information between the various devices. And that intelligence may only be owned by certain groups, and so somehow we need to collaborate collectively in a global way to correlate the information that is collected on these edge devices and share that information. So suddenly sharing of information is going to become very critical. The other thing that needs to be taken into account is that security controls have to now integrate into a software-defined environment. So no longer can we rely on just, say, maybe Wireshark collecting the information at a network layer, because the very nature of that network could be dynamic and impacted by the changes at the software layer. We now need to think about how do we integrate into that software layer. And at the same time, we still need to be able to, in these hybrid environments, collect the information from the on-premise environments so that we can start collecting and correlating all that information from an internal perspective. We also need to think, how do we manage the security controls where edge-to-edge has become more prolific? And how do we control access at the gateways to only allow authenticated traffic to go between the IoT device and the core cloud? Just the very nature of the 5G network means that volumes of data will be magnitudes of order of greater than what they are now. And so that means that the traditional approaches that a lot of organizations still currently have is not going to work going forward. That volume of data is just going to be so vast, and the ability to triage that data just cannot be done physically by human operators. So we're going to have to start thinking around what techniques can we implement now within this IoT 5G environment that we can start to be able to manage and triage this data in an automatic, repeatable and reliable way. Of course, we mustn't forget the fact that there's going to be multitudes of different types of IoT devices producing different types of information and using different techniques and being implemented for different purposes. And so somehow we need to come up with a generic interoperability between all these various different devices. And again, that will require some form of standardization. Added into this complexity of volumes of data, the edge-to-edge manipulations, the software-defined networks, we still have to understand, how do we manage all this information that is collected, the security event information? How do we manage it and identify where there's a security incident using decentralized models in a centralized way? So that's yet another challenge that we have to take into account. So these problems that we have now, people are already working on them, and there are lots of different solutions out there, and it's just about bringing them all together and making them all compatible and interface with each other. So this will drive new approaches and new techniques to managing these environments, and will certainly be ramped up over the next few years as 5G gets officially rolled out. So the thing here is that we need to start preparing now if you think you're going to be using IoT integrated with 5G communications in the future. So strategies need to be thought about now. And what those strategies need to do is identify how you're going to securely manage these IoT devices. So maybe one of these techniques that you're going to use to help identify a poorly configured or incorrectly placed IoT device could be using a website like Shodan. So the Shodan is where it allows you to potentially identify IoT devices that are sitting on the internet and easily accessible. It will allow you to identify those which can be or are carrying certain vulnerabilities and are potential to exploitation. Because of the very nature of these devices, the fact that they can be exploited, but they're also connected up to your internal network potentially, they could become a gateway for an attacker to come and compromise your environment. So another key thing that we need to think about is establishing a risk management framework that will incorporate fully the IoT and the 5G environment. So this will provide a framework that focuses on how to manage and balance the risks associated with the security, the safety, the privacy of these devices. Of course, a key one, which I'm sure you're already doing on your own networks currently, but should be applied to the IoT devices, security hygiene. Make sure standardized builds. Make sure that the correct patching is in place, and making sure that it undergoes the same security management that you're doing with your on-premise or your cloud environments. Perhaps when you're going to buy the next IoT device for whatever purpose, perhaps you should start thinking about the requirements that you want the manufacturer to provide to you, to demonstrate to you, or your supplier who is configuring that device for you. Perhaps you could pre-plan and identify what those requirements will be. And this will help you ensure that the security hygiene that we just mentioned and all the other access controls, authentication mechanisms, storage, processing, it's all in place and you know that you're getting the device that you need. Other concepts that you might need to take into account is implementing a no tolerance, zero trust network policy so that you can control whilst you can't control the motivation of an attacker and what data they're trying to get into your network, what you can do is control how you respond to their behaviors. And so that means that you can start bolstering your IoT security and safeguard mitigation methods for some of these risks that we've mentioned of the connected IoT devices by implementing these types of strategic approaches, risk managed, and understanding how the technology works and knowing where the controls exist at the right layers within those devices. You will need to train your staff so that they can identify the right security tools that will support what you need and give you the required network/application visibility so that you can then start to now think about analyzing behavioral analytics, AI analytical capabilities, rather than the traditional just capture the events, read through it yourself, and try and identify weaknesses or unusual activity through that triage process. So by designing stronger security measures now, this will result in cost savings in the future for your enterprise and will hopefully increase the barrier for an attacker and reduce your likelihood of having a data breach. So despite these security challenges associated with the IoT technology, it does have the potential to transform everyone's lives and user experiences and will revolutionize tomorrow's living. I find that really exciting and I'm really looking forward to where we can go with it. But we do need to take a multi-layered approach to mitigate these security risks that have been mentioned. So, define a strategy. Ensure that you can reduce your risks, and especially if you're anticipating that you're going to be using 5G-enabled IoT devices. Also, anticipate the fact that no matter what happens, your network could accidentally have a vulnerable IoT device connected to it. How are you going to manage that? So hopefully some of the things that we talked about earlier will provide you with the right frameworks, with the right policies and with the right approaches to be able to manage for such a scenario. And now a plug. So if you'd like to learn more about IoT devices and how they're integrated into the operational technology space, then this Thursday, 8th of October, BSI will be presenting the IoT and OT Bridging the Security Gap. And as you can see, we'll have the three presenters here and colleagues of mine who will be presenting on Wednesday if you'd like to join that session. And now I should go to any questions. Thank you very much for your time.